Welcome, everyone, to the first session of Plasma Pro Tips, a series crafted to boost your skills with ICP-OES and ICP-MS systems, with short, practical advice. We're excited to introduce our newest technical team member, the Plasma Professor, who'll be our guide throughout this series. Each month, we'll tackle a common issue with your sample introduction system. If you've got a question you'd like the Plasma Professor to answer, just leave a message in our online suggestion box. Now, let's dive in and meet the Plasma Professor.
Thank you and welcome everyone to Plasma Pro Tips. Plasma Professor here, and today we're focusing on nebulizer backpressure, a key indicator of system performance. Nebulizers are designed to operate within a specific pressure range, and an unusually high or low backpressure is a warning sign that something's off, and you'll need to address it before starting your analysis. It's always good practice to note your nebulizer backpressure once your instrument's warmed up and the ICP is running smoothly. That number will serve as your benchmark, so if it ever significantly deviates from this reading, you know there's an issue that needs to be addressed. Let's also take this opportunity to break down glass expansion nebulizer part numbers, since the nomenclature contains important details about backpressure. For example, in these two part numbers, A13-1-UM04 and A13-07-USS2. The middle digits, a 1 or an 07, indicate the recommended nebulizer gas flow, with 1 indicating 1 liter per minute and 7 indicating 0.7 liters per minute of argon. At the specified flow rate, glass expansion nebulizers are designed to operate at 40 psi, or 275 kilopascal. Thus, your benchmark backpressure should be close to 40 psi. This value may deviate slightly depending on your instrument optimization and method parameters, but it should be approximately 40 psi. If your nebulizer backpressure is below your benchmark, often in combination with a loss of sensitivity, you're likely dealing with a gas leak or a damaged nebulizer. First, start by checking the gas tubing and connections at the instrument and nebulizer. A gas leak will result in a backpressure well below the optimal level, which in turn produces a poor, often pulsing aerosol with larger droplets, leading to a decrease in sensitivity and stability. Glass expansion's direct connect, or DC, gas fittings are designed with built-in torque control for a secure, reliable seal. We also use large, soft-walled gas tubing to avoid kinks or wear, which is typically associated with rigid capillary tubing. If all the connections are tight and secure, you should then inspect your nebulizer for any damage or wear. It is easier to carefully inspect the nebulizer tip with a magnifier, such as our magnifier inspection tool. Now, if your backpressure is higher than your benchmark, you're likely dealing with a blockage or clog. To address this, remove the nebulizer and clean it carefully with the recommended reagents and tools, not only to ensure proper cleaning, but also to prevent any damage to the nebulizer. The LUO device is the recommended cleaning tool for all glass expansion nebulizers. Regular maintenance keeps your nebulizer performing at its best and maximizes its lifespan. You'll find detailed cleaning guides and videos on using the LUO on the Glass Expansion website. And here's a tip to improve nebulizer maintenance schedules. Start and end each analysis by running a mildly acidic blank solution, followed by deionized water, each for 5 to 10 minutes. This will prevent deposits from building up in the capillary tubing or nebulizer orifice. If you're using the right sample introduction system for your sample types, high nebulizer backpressure shouldn't be a frequent issue. If these interruptions do occur, you'll need to determine the cause of the blockage, which is most likely due to either particulates or salt deposits, and then adjust your sample introduction configuration to prevent them from happening. And this is where our Guardian product line can help. The first member of the Guardian family is the Guardian Inline Sample Filter, which installs directly onto your sample uptake or probe tubing, and uses a 120 micron peak filter to catch large particulates before they clog or damage your nebulizer. The best part is that it's reusable. When it traps a particulate that would otherwise clog or damage your nebulizer, just backflush it with the LUO and Guardian adapter, and you're back in business. We're also thrilled about the newest member of the Guardian family, the Guardian Autosampler Probe, a significant upgrade from standard PTFE encapsulated carbon fiber probes. With options to fit all standard autosampler models, it features a durable ceramic tip that resists damage from misalignment, a drip-resistant design to prevent cross-contamination, and a built-in particle filter to keep your sample line clear. The other common type of blockage is salt deposition at the nebulizer tip, a frequent headache with high matrix samples. That's where an argon humidifier comes in, which is typically essential for these types of samples. Glass Expansion's Allegra Argon Humidifier is a compact, entirely inert design with no metal fittings, and neither pressurized nor requires any power. It delivers approximately 95% relative humidity, reducing salt buildup, stabilizing your signal, and extending the life of your nebulizer, torch, and interface cones. Let's recap what we've covered. Set a benchmark for your nebulizer backpressure to catch issues early. Any abnormally high or low backpressure needs to be addressed. Low backpressure? Check for gas leaks or nebulizer damage. High backpressure? You've got a blockage. Clean the nebulizer with tools like the LUO. We also highlighted accessories like the LUO, Magnifier Inspection Tool, Guardian Inline Sample Filter, Guardian Autosampler Probe, and Allegra Argon Humidifier to keep your system running smoothly. You can find all of these options, along with more detailed maintenance and troubleshooting procedures, at geicp.com.
Thanks, Plasma Professor, and thanks everyone for joining us for this Plasma Pro Tips session. We look forward to seeing you next time, and don't forget to submit your questions to the suggestion box. Until then, happy analyzing!